Hello friends, welcome to SahuStudies. In this video, I am going to discuss about how ReduceByKey function works in PySpark. So why do we use ReduceByKey? So ReduceByKey is a transformation function. It is a wider transformation function. And why we generally use ReduceByKey? Whenever there is a requirement to merge the value of each key, we use ReduceByKey function. It uses associative reduce function on the PySpark RDD to merge the value of the each key. So this each key, it is very important. So for instance, we have a data frame, and that data frame we created partition based on a particular column. So it will going to create one partition based on the unique value which is present in the column based on what we are just creating a partition. So what ReduceByKey function will going to do, it will going to merge the each value which is present in that partition or which is present in the each partition. It is a wider transformation. So whenever there is a transformation which is wider, so there would be a lot of shuffle operation will going to perform, and that is a very costly operation. But ReduceByKey, it is a design in such a way that the shuffle operation will going to happen at the last stage of the transformation. That's why it is not a very costly operation. So for instance, this is the data. And we are partitioning the data based on the key column. So how many partition it will going to create? It will going to create one partition for IT, one partition is for operation, one partition is for management, and one partition is for the marketing. So there are 4 partitions it will going to create. And if we are adding the aggregate function such as add, so what it will going to do, for each key it will going to add and combine into one value. We can see the output here. The output is like IT has 5, means all the value which is present in this partition of ID, each value is adding and the output would look like this. For the operations has 8 value. We can able to see here there are 8 records which are present in the operation, and each has 1 value. That's why it is performing some aggregation and give the output as 8. Same goes with management and same goes with marketing. Now let's try to understand with the help of this pictorial representation how the reduce generally works. So suppose this is a one partition, right? It has a value A1 and B1. What it will going to do, in the same partition only, it will perform this aggregation. Means it will, because A has only one value, B has only one occurrence, so it is just aggregating like this only. Here there are 2 value of A1, 2 value of B. So how it is reducing? It is reducing in the same partition, A2 and B2, because we are doing the sum operation. So it is taking the value of A, so 1 and 1, it is 2. It is taking the value of B, 1 and 1, so it is 2 here as well. Now this is a separate partition. So for A there are 3 values, so it is aggregating based on the key on the same partition. So A and the total number of value is 3. Here also it has 3 value of B, it has value 1 it has value 1. It is aggregating on the same partition and it is giving the value b is equal to 3. Now, once this has been done, at the final stage, the shuffle operation will going to perform. So what the shuffle operation going to perform, what it will going to do, the data will be shuffled between different partition, or we can say the data is shuffled between different executors because executor has those partitions. So two partitions gets created, one is for A and one is for B. So all the values which is present here, here and here, it is coming up here and final aggregation is taking place. So here we can say for the A, from here A1, from here A2, because this is the final output, and here what is the final output, A3, so it is coming up A3, and what is the aggregation of the sum aggregation of these two values which is performed in the same partition. This is A is equal to 6 because one value 1, 2 and 3, if you sum up it will be 6. Same for the B. This one B1 is coming from this partition, this B2 is coming from this partition, and this B3 is coming from this partition, and within the same partition it is aggregating the sum aggregation, and this output has come, that is B is equal to 6 because 1 from here, 2 from here and 3 from here, then the total is 6. So in this way, if you talk about how it is performing in the each partition, how the shuffling is happening at the last stage of the transformation, so we have seen with the help of this pictorial representation. Now let's do exercise, right? So what I am doing in this exercise, this is the data set on which I am going to do a reduce by key operation. Here I am just importing this add operator. Here I am creating a RDD with the help of this parallelize method by passing this list variable which has the required data. Now I am creating a RDD. This RDD will going to created by calling the reduce by key function on top of this RDD, and we are just calling the add. Means RDD will going to do a operation transformation, addition transformation based on the each key, and whenever we are going to print the collect now, so whatever the value which is present in this key after the aggregation, it will going to print out. This second block of code, what I am just doing, I am again calling this reduce by key function on top of this RDD, and I am just creating a lambda, creating a function with the help of a lambda. So how the function is getting created? I am passing two parameters, AP smallest and AP current. It will return AP smallest if AP smallest is less than AP current, or it will return AP current. So this value, this RDD has the lowest value which is present here. So one thing is very important. This lowest I am just talking about now, it will not going to perform on the whole sets of data. It will going to perform on the partition. So for it will going to calculate what is the minimum value in the partition which is which has key IT. Sorry. Another value it will going to create what is the smallest value which is present in the partition operation. Same for management and same for operation. So it will going to calculate the minimum value which is present, the minimum value of that partition in which it is going to operate. So if an RDD has a 10 partition, so 10 minimum value it will going to return based on the each key. Here again what I am just doing, I am just calling this reduce by key function on top of this RDD. I am creating a lambda function with the help of a lambda, passing two parameters, AP largest and AP current. It will return AP largest if AP largest is greater than AP current, else it will return AP current. And whenever we are going to print the max this RDD with the help of a collect, then the maximum value will going to come. I have also captured the output. the first print statement, this one, what it will going to do, it will just aggregate all the value per key. So operation has 127, IT has 14, management has 53, and marketing has 43. The This is the second print statement where I am just figuring out what is the lowest value. So for the operation it is 1, for IT it is 1, for management it is 1, and for marketing it is 1. The third print statement, this is the output of third print statement. Here we are just figuring out what is the maximum value of each partition with the help of a reduce by key. So here it is saying in operation the maximum value is 120. For the IT maximum value is 10. For management maximum value is 50. And for the marketing maximum value is 40. So whatever the exercise I have shown here, let's do this exercise on Databricks. Let me create a notebook. Name it as ReduceByKey Function. To perform this ReduceByKey Function exercise, now we need some data. So I have already created. This is the list which I am just defining. It has some data, key and values. So let me run it. Now this list variable has been defined successfully. It has all required values. Now from operator, import add. Run it. Now create a RDD object. How we are going to create RDD object? With the help of a Spark context and calling this parallelize method by passing the object which has data. So this AP sample data is a list variable which has the data. So let's pass this variable here and run it. Now this RDD has been created successfully. Let's do a reduce operation or reduce by key operation here. AP reduce by key RDD, because this would be a RDD object. That's why I have given this naming convention. And here on top of AP, let's create reduce by key and pass this function. Let's run it. This RDD has been created successfully. This RDD has a record which is generated by the reduce by key operation. And which kind of aggregation function we are doing? We are doing addition function. So for each key, one record will be present in this RDD, and the value would be the sum of the all value which is present here based on the key. Like for IT, it would be one value, for operation it would be one value, for marketing it would be one value. Right. Let's print. We can see, right? Print dot collect. We can see. We can see for operation, this is the aggregate, sum aggregate. IT, this is the sum aggregate. Management, this is the sum aggregate. Marketing, this is the sum aggregate. Now let's write another code to find out what is the minimum value per key with the help of a reduce by key function, right? So let me create another RDD, reduce min. Sorry. So let's, on top of this RDD, let's do a reduce by key, and I am going to create a function with the help of a lambda, and passing two parameters. One is smallest, another is AP current. What it will going to do? Return AP smallest if AP smallest is less than AP current, else return AP current. Run it. Make it RDD. Okay, so naming convention it would be RDD. So let me print dot connect. We can see here for each partition what is the minimum value it is giving. So what I am just doing here on top of this RDD, which has all the data, okay, I am calling the reduce by key and I am passing a function. So here with the help of a lambda, I am creating a function passing two parameters, AP smallest and AP current. So what it will going to do, it will return AP smallest if AP smallest is less than AP current, otherwise it will return AP current. That's why if you see here, by printing this RDD, it is just giving the output the smallest value of each partition. Each partition means each key. Let's figure it out what is the maximum value of each based on the each key. Okay, so AP reduce max RDD. Let's call the reduce by key function and pass the function. So let me create a function with the help of a lambda AP largest and AP current. There are two parameters which I am passing. Return AP largest if AP largest is greater than AP current, else AP current. Return AP current. Let's run it. Let me print this RDD. Collect. Okay, what is the error? Let me AP largest. Okay, I think it has. Now it will work. Okay, we can see it is printing the largest value of each key or each partition. Operation has 120 as the largest value, IT is 10 as the largest value, management has 50 as the largest value, this marketing has a 40 as the largest value. So what I am just doing here, I am just calling reduce by key on top of this RDD which has all the data. I am creating a function and passing two parameters, AP largest and AP current. It will return AP largest if the value is if largest is greater than AP current, else it will return AP current. So in this way we can do aggregation, maximum aggregation for each key, and we can see this is the maximum value of each key which is present in this RDD. So in this exercise we have seen how the reduce by key function generally works, how we can write a code to perform a aggregation on top of a RDD with the help of a reduce by key. So in this exercise we have done exercise and based on three aggregate function. One is addition, one is minimum, and one is maximum. Thank you. If you like content of my video, then please subscribe my channel, like it, comment on it, and press the bell icon to get notification whenever I add videos.